Today we're going to be talking about lesson 4-4, polygon interior angle sums. You're going to want your geometer today and possibly a calculator. So if you would like to pause the video, you can get the learning intention jot down, grab that geometer, grab that calculator, and come back. Okay, so today's learning intention is I will learn how to solve for polygons using interior angle sum theorems. So we're going to be learning a new theorem today and finding the sums of the interior angles. So first of all, we are going to look at polygons by the number of sides. And so the first one we're going to talk about is three-sided polygons, or a triangle. This is number 13. I'll write that down for you on your geometer. So if you'd like to use number 13 right now and get that down. Okay, so we're going to classify these by number of diagonals. And the first one might be a little bit confusing, but we'll get into it more, and then I think it'll make more sense. So if I were to try to draw from an angle to another angle or a vertex to a vertex, I can't here. So this one's just going to have one. It's going to have one diagonal. And the interior sum, like we already knew a triangle had, is 180 degrees. And we're going to see a trend here in a second. And we'll make note of that as soon as we see it. So the next one I'm going to use is a four-sided polygon. This is number 7. So if you'd like to use number 7 on your geometer and get this one down. So if I were to connect this one from vertex to vertex, or divide it in half, I were to get 1, 2. So this one is considered to have 2 diagonals. And anytime I have 2 diagonals, or I take the number of diagonals, I guess I should say, take that times 180 degrees. If you'll notice, I have now split this into 2 triangles. So I have 180 degrees here, 180 degrees here. So if I simply take 180 degrees times 2, I'm going to get 360 degrees. So that is the sum of all of these angles added up. Okay, just like a triangle, 180 is the sum of all these angles added up. And if it makes sense, I'm splitting it into 2 different triangles. 180 times 2 is 360. Okay, so my next one, we're going to do a 5-sided polygon. This is number 11 on your geometers. Okay, so if I were to take this and use my vertices and split this up, hopefully maybe yours will be a little bit neater than mine. I can see I have 1, 2, 3. So my number of diagonals is 3. And if I take 3 times this 180, you should get 540 degrees. So if I were to add up all of my interior angles on a 5-sided polygon or a pentagon, I would get 540 degrees. The next one we're going to look at is 6-sided, or a hexagon. This is going to be number 14 on your geometers. All right, so if I were to take this one and do the same thing, all right, I now get 1, oops, sorry about that, 1, 2, 3, and 4. And we have 4 diagonals. If I take 4 times 180, I get 720 degrees. Okay, so then we're going to use an N instead of keep going. We're going to find the trend here. So that way you can find the information for any sided polygon. And N we learned is an n-gon. We're not going to draw anything because it could be any sided figure. The number of diagonals, the way we're finding this is we are taking the number of sides, if you look, and look at the relationship. 3 to 1 is 3 minus 2 is 1. 4 minus 2 is 2. 5 minus 2 is 3. 6 minus 2 is 4. So to find the number of sides of an n-gon is simply n, which is n is the number of sides, minus 2. And that is the relationship of all of these. Then, to get the interior angle sum, we took this number, our number of diagonals, and we times it by 180. So this is simply going to be our n minus 2, which is all of these, times 180 degrees. Okay, and I do think you will find these formulas, the interior angle sum on your formula card. So you will get that for your test, so that's good. So let's go over here, and it says find the interior angle sum of each polygon below. Okay, so interior angle sum, that is what is specified here. And now we have a decagon. So we don't have that in our chart to look at, but we have the formulas down here. So this row is going to be key to your assignment in helping. So a decagon, to find the interior angle sum, we know it's n. N being the number of sides, we know that a decagon has 10 sides, minus 2 times 180. Okay, and you should come up with 1,440 degrees. Okay. Okay, a heptagon. A heptagon has how many sides? 7. So it's this formula right here, minus 2 times 180 equals, and you should get 900 degrees. So this is the sum of the interior angles of a heptagon. Okay, we're going to try a 20gon. Nothing different. It's the same process, the same formula. So we have 20 sides minus 2 times 180, and you should get 3,240 degrees. Okay, so every angle of a 20gon added together will get you 3,240 degrees. Okay, so a 15gon, same formula. And this should give you 2,340 degrees. All right, so we're going to go down below, and now it's asking us to find each interior angle. Okay, so not the sum of the angles, each interior angle. Okay, so by doing this, we can take the sum, like what we found here, and we can divide it by the amount of angles. Okay, so the triangle, the interior angle sum, is what we need to have first. So we're going to do this one. We can look at our chart to find a triangle. We have it on our chart, which is 180 degrees. And we're going to divide it by how many angles there are. A triangle has 3 angles. Okay, so we know that each interior angle is going to be 60 degrees. Okay, likewise over here, we have 4 angles, 4 interior angles. We do have this one on our chart. The interior angle sum over here is 360 degrees. We will take that divided by how many angles it has. It has 1, 2, 3, 4. Okay, so this one you should come up with, and if you don't know, you can use your calculator, 90 degrees for each one. And look, they do show that they are each 90 degrees. 90 degrees for each one. Okay, so down below, we're going to find the interior angle for each polygon. Okay, All right, pentagon. Pentagon we have in our chart right here. So we know that the interior angle sum is 540. And we simply divide this by the amount of interior angles, which is 5. A pentagon is 5. So you should come up with 108 degrees. Meaning each interior angle of a regular pentagon, regular means that they're all the same, is 108 degrees. Okay? So a regular octagon, we do not have an octagon on our chart. So first we need to find this number here, this interior sum. And we do that with this formula here. So an octagon, meaning we have 8 sides minus 2 gives us 6. And then we times that times 180. Or I can just put the 180 after this. So 6 times 180. And we should get this number here. And then you just take that divided by the number of angles, and you should get 135 degrees. So if they are regular, if they are all the same, they will each be 135 degrees. Okay, a dodecagon has 12 sides. So once again, using this formula here, it's not on our chart. So we need to find the interior angle sum, which is 12 sides minus 2 times 180. And this equals 1,800, which is 10 times 180. Now, if it's regular, we just take it divided by the amount of sides because they're all going to be the same. And we should get 150 degrees for each interior angle. Okay, a nonagon, we know is a 9-sided polygon. So 9 minus 2 times 180. We should get 1,260. Once again, it says it's regular, so we can just divide it by the amount of sides because they're all going to be the same. And we should get 140 degrees. Okay. All right, moving on. Now we're going to find the value of x, then the value of each angle. So x first, and then each angle. All right, so number 1, we have a triangle. We have 2 interior angle amounts, or degrees. We are missing 1. We have learned that triangles equal 180 degrees. So we simply know that we can find x by taking 180 and subtracting these and getting x. Okay? And if you plug this into your calculator, you should get x equals 28 degrees. So these angles are given. The missing angle is 28 degrees. Okay? Over here, we need to find the measure of angle A, angle B, angle C, D, E, and F. So wherever you guys have room. Okay? So before we do this, though, we need to solve for x. So first, we need to know the interior angle sum. What is the complete sum of this interior polygon? So we need to know how many sides and how many angles it has. 1, 2, 3, 4, 5, 6. Now we know we are dealing with a heptagon. We are dealing with a 6-sided polygon. So if we go back, we see the formula here, or we have it on our chart. So a 6-sided polygon, the interior angle sum is 720 degrees. So we know that the whole inside of this, all of these angles added up together will equal 720 degrees. So if we add all these together, or if you can see that you can combine like terms from the beginning, we can just do that. So we have how many x's? 1, 2, 3, 4, 5, 6. We have 6 x's. And then our next like term, so we have a 2 minus 8 should give you a minus 6 plus 7. We should now be at positive 1 minus 3. We should be at a negative 2 plus 6 should be at a positive 4. And then minus 4 puts us at 0. So we don't need to do anything for that. It's just 6x minus 720 degrees, and we are solving for x. So you should get x equals 120. Okay, we are not finished because we need to find the value of each angle. So we take the x that we have and we plug this in for every x. So for A, we would take 120. Oh, and this is not degrees. I'm sorry. This is not degrees. It's just a value. We take this 120 and plug it in for x. So 120 plus 2, you should get 122 degrees. So B, you have 120 minus 8. You should get, if you plug it into your calculator, you should get 112 degrees. C, 120 plus 7 should give you 127 degrees. D, 120 minus 3, you should get 117. 120 plus 6 should give you 126 degrees. And 120 minus 4 should give you 116 degrees. If you wanted to check yourself, you could simply add all of these together. And you should come up with the interior angle sum of 720 degrees. Okay, so this does check out. All right, let's look at number 3. Okay, first thing we need to know is the interior angle sum. So we know we have 1, 2, 3, 4, 5. We know we have a 5-sided polygon. This is on our chart. So we know that the interior angle sums are 540 degrees. So we know that this is going to equal 540 degrees. Okay, so solving for x, we can go find like terms. We have 4x plus 7x plus 4x plus 5x plus 6x. And that gives me 26 x's. I'm going to move this over just a tad because we're going to be finding the measure of A, the measure of E, the measure of D, the measure of C, and the measure of B. Okay. So, like I said, we have 26 x's. All right, and now for our next set of like terms, we have a positive 5. And then we have a minus 5, which brings us to 0. And then we have a plus 10 and another plus 10, so that should be 20. Okay, and that's going to equal this number here. Okay, now we're just solving for x. All right, so I'm going to cancel these out. I have 540 minus 20, and that gives me 520. I have 26x equals 520, and solving for x, you should come up with x equals 20. So now we take this x, this 20, and we plug it in for all these values to come up with our angle measures. So 20 plugged in here, you would have 4 times 20 plus 10, and you should come up with 90 degrees. E is just 7 times 20. You should come up with 140 degrees. D, plugging 20 in for x, you should get 85 degrees, C, 95 degrees, and B, 130 degrees. And once again, if you wanted to check them, you should come up with 540 degrees. All right, go ahead and work on your homework and let me know if you have any questions.